Today we're going to talk about topic 2.10, finding derivatives of tangent, cotangent, secant, and cosecant. Okay, so you might recall the derivative of sine we know is cosine, and the derivative of cosine we know is negative sine from the previous topic. But we have four more trig functions, right, that we need to worry about. So the derivative of tangent, derivative of cotangent, derivative of secant, and derivative of cosecant, okay? So, I have them in this little gray box here. You can always use them for reference for any worksheets or anything I send home online. Okay, but I have a little activity here, and normally I would have you do this, or I would challenge you to do this on your own. But I want you to prove that the derivative of tangent is going to give me secant squared. And ultimately, it's just a chance for us to practice using some of the rules and properties that we've learned over the last few days. So what I'm going to do is I'm going to take the derivative of tangent, okay? That. And ultimately, before I take the derivative of tangent, I'm going to write tangent as sine of x over cosine of x. Now, if I take the derivative of that, I need to use my quotient rule. I have a quotient of two different functions. So when I do that, I'm going to start with the low times the derivative of the top. Now, the derivative of sine is cosine minus the top times the derivative of the bottom, and the derivative of cosine is a negative sine, all over the bottom squared. Okay? Remember, the bottom is not a derivative, it's just the denominator squared. So if I start to piece this together, I get a cosine squared x. Now I have a minus sine x times a negative sine. That's going to end up being a positive sine squared all over cosine squared x. Now, if I do this, we know the trig identity of cosine squared plus sine squared is just the Pythagorean identity. So it's going to be a 1 over cosine squared x. And I can write 1 over cosine is just secant squared x. And that's our proof for the derivative of tangent. Okay? So we used kind of a little quotient rule. All right. Now we can do the same idea for cotangent. All the steps are relatively the same. If you would like to do it, pause the video. But I know cotangent is cosine over sine. So I'm going to use a quotient rule. So low, get my pen working here. Times the derivative of the top, which is a negative sine of x, minus the top, which is cosine. Derivative of the bottom is another cosine, all over the denominator squared. So I'm going to get a negative sine squared x minus cosine squared x all over sine squared. Now we almost have that Pythagorean identity, but if you notice, it's multiplied through by a negative. So I'm just going to take that negative out, factor it out from the top, and I get a negative 1 over sine squared x, which is a negative cosecant squared of x. And that is my proof for the derivative of cotangent. Okay? Now, parts C and D, we're going to do very similarly, but they come out a little uglier. Okay? Derivative of secant is still secant, but I get a tangent multiplier. So derivative of secant is secant tangent. The derivative of cosecant is still cosecant, but I have a cotangent multiplier. It's also negative. We'll talk about that at the end. But if I go through this proof, I'm going to take the derivative of secant is 1 over cosine. So I'm going to do a quotient rule here, as crazy as that sounds. I'm going to do a low times the derivative of the top. Now, the derivative of 1, because 1 is a constant, is 0 minus I. D low, the derivative of the bottom, is a negative sine of x all over the bottom squared. Now, when I do this, anything times 0 is 0, so the cosine of x times 0 goes away, and I'm left with just a positive, because a negative 1 times a negative sine would be a positive sine x all over cosine squared x. Okay, now, the only thing is I want to show you how we're getting that secant tangent. Okay, so I'm going to write this as sine x over cosine x times 1 over cosine x. If you notice, I still have 2 cosines in the denominator, 1 sine in the numerator. I just split it up. And sine over cosine is tangent, and 1 over cosine is secant. They wrote it the other way, but I get a secant x tangent x. Okay? So that is my derivative. Let's do one more. Again, feel free to pause it, do it on your own. Okay, we're going to do this very similarly. So I'm going to take the derivative of cosecant, which is 1 over sine. I'm going to do a quotient rule. So low times the derivative of the top minus the top times the derivative of the bottom, which is just a cosine, all over the bottom squared. Sine times 0 is 0, so I'm just going to get a negative cosine of x all over sine squared of x. I'm going to write that, I'm going to separate it to be a negative cosine x all over sine x times a 1 over sine x. So I just kind of separated the fraction into a product of two things. So I have a negative cotangent of x times cosecant of x. Or I think they write it as a negative cosecant x cotangent x. Okay, so that is my derivative. Now, I would go through, and again, I would probably make flashcards, so a quick reference guide, right? So that way, if you're taking a quiz, test, homework at home or online, you can just pull those flashcards out and get a quick, easy derivative if you're needed. But I would put all of these in the same place, so that way you can reference them fairly quickly. Okay. Now, just as a quick application, right? So you can see them together. I have a function of x minus tangent. Well, I'm going to use sum or difference rule. So the derivative of y would be a dy dx. Again, I'm trying to use good notation. You could also use a y prime if you wanted. Is going to be a 1 because the derivative of x is just 1 minus the derivative of tangent is a secant squared. And this would be the equation for my derivative. This could give me the slope or the instantaneous rate of change at any point. Okay, so if you look at this next one for part B, a little bit more work because I have x times secant. Okay, it's a multiplier, so I have to use product rule. So in part A, I had a sum or difference. In part B, I have a product. So I'm going to say dy over dx equals. Okay, I'm going to take the derivative of the first, keep the second, plus, now we're going to keep the first and take the derivative of the second. And the derivative of secant is secant x tangent x. Okay, now if I write this, I'm going to have a secant x plus x secant x tangent x. And I always like to write things in a variety of ways just for multiple choice purposes. So I can also factor out a secant Oops, I forgot my tangent. Okay, and this would be another way to write the same solution. Okay, so both of those would be acceptable answers on a free response. Multiple choice, just be aware they might do some factoring. Okay, so questions are the same. It's just with more complicated functions, or new functions, I should say. All right, so take a look at example 2. Again, questions are the same. Can you write the equation of the tangent line? Now they give me 2x tangent of x. Now I need a point and I need a slope. I know x is pi fourths, so I want to figure out what f of pi fourths is. So I'm going to do 2 times pi fourths times the tangent of pi fourths. Okay, now you should be able to do this without a calculator. Just throwing that out there. Okay, 2 times pi fourths would be a pi halves. And then tangent of pi fourths, well, tangent is sine over cosine. Sine of pi fourths is the square root of 2 over 2. Cosine is the square root of 2 over 2. So since sine and cosine are the same, tangent of pi fourths is a 1. So I know f of pi fourths is just pi over 2. So my point is going to be pi over 4, comma, pi over 2. So that's the first step. Find your point. Now we want to find our slope. So I'm going to take the derivative of f of x, which if you notice, I have a product. I have to do product rule. So we're going to take the derivative of the first, derivative of 2x is 2, derivative, and then keep the second. So we don't do anything there. Plus, now keep the first, derivative of the second, derivative of tangent is secant squared. And now we need to find out what f prime of pi over 4 is. So I have 2 times the tangent of pi over 4 plus 2 times pi over 4 times the secant squared of pi over 4. Okay, so we got a lot of stuff to figure out here. So 2, we said tangent of pi over 4 is going to be 1. We did that earlier. 2 times pi over 4 is just a pi over 2 times, now secant squared of pi over 4. So secant is 1 over cosine, or the reciprocal of cosine, right? So cosine of pi over 4 is going to be square root 2 over 2. So that means secant of pi over 4 has to be 2 over root 2. And if you rationalize this denominator, because it does make it easier, I get 2 root 2 over 2, or just the square root of 2. So I'm going to have the square root of 2 squared. So I get a 2 plus pi over 2 times 2, or in this case, a 2 plus pi. So this is my expression for the slope. Now we don't want a decimal there. We're going to leave it exact. So now my tangent line is a y minus my y value times my slope, x minus my x value. And I'm going to get this y equals, and this would be my tangent line. Okay. All right. So again, the name of the game here is just to know to know all 6 trig derivatives. You need to know those by heart. They have to be automatic. So practice, practice, practice. These are the proofs of how we got them, but just know they're going to start to get incorporated into our product rules, our quotient rules, our sum difference rules. So make sure that you can apply those derivatives, as well as the questions about tangent lines, maybe a horizontal tangent. Those are all going to be the same. So make sure you know those 6 trig derivatives, and that will conclude Unit 2.